Hi, my name is Michael Lee, and I'm your host for this brief but spectacular overview of early Shlaer-Mellor software architectures. I met Stephen in 1976, Sally in 1979, and had the pleasure of working with them on many projects over the years. Today, we're going to take a look at how their method and the practice of their method evolved in the early days. Let's get to it. Here's the timeline of the early Shlaer-Mellor days. At the top in red, you see the significant events in the evolution of the method, starting with the founding of PT, various publications on the method, and ending with the ACM debate between Stephen and Grady Booch on translation, myth or reality. I think this was a key aha moment in the software engineering community when they realized that Shlaer-Mellor was up to something a little bit different. The bottom in blue, you'll see the three projects we're going to talk about today. They're about 6 years apart each. The first project that we'll look at today was in the early 1980s, before any books on Shlaer-Mellor were available. I was the architect on this project, and Steve and Sally were consultants. The system was a real-time process control system that managed aluminum rolling mills that processed metal at up to 600 feet per minute. A system in which a software bug could have a very dramatic effect. The platform we deployed on was a ModComp real-time minicomputer with a priority-based preemptive scheduling system, and the language was Fortran, believe that? At this point in time, guidance for the software architecture was very rudimentary. This is evidenced by this 3-sentence definition Steve and Sally provided. However, the separation of the application from the implementation and the role of the architecture were perfectly clear even at this early point. Let's look at the software for this system now. Here you see the details of the application analysis. Of particular relevance, another aha moment I believe, was the modeling of all the data in the system using a textual entity relationship model, clearly an initial step toward an object-oriented approach. Also of interest was the use of state machines for control, although these were functionally oriented state machines, not object-oriented ones. And finally, note the rudimentary tools for analysis, a CAD drawing system and a text editor. On the architecture side, a significant automation effort was put into the organization and accessing of the data, which, if you can believe this, made the Fortran code look very object-oriented with respect to data and hid all of the nasty characteristics of Fortran's global comment. A good thing. The state machines, while not generated automatically, were implemented in a very prescriptive manner, and the regular patterns in the architecture offered numerous opportunities for online, offline, and testing tools, which greatly facilitated the development and deployment of the system. All of this led to a significant reuse of the architecture on multiple rolling mills. And the startup in the factory went very smoothly with respect to the software, which was never on critical path. The second project we'll look at is 6 years later in 1988. At this point, Steve and Sally's Modeling the World in Data book had been published. I was the architect on this system, and Leon Starr consulted as an analyst. His first gig at this, I believe. This system involved the automated transport of assemblies and parts in the manufacturing of an AT&T telephony switch via conveyors, automated guided vehicles, carts, etc. This was basically a soft real-time system. The platform we deployed on included AT&T 3B2 computers, Allen Bradley PLCs, and on the computers, we use Unix, C, and an Infomix database. The guidance for the software architecture was a bit better documented at this point in the system design phase chapter of Modeling the World in Data. This contained what I believe was another aha moment when they said about the architecture, and I quote, "These are the cosmic decisions which, if made well, will outlive all the programming." I think this clearly put programming versus architecting in relative perspective for Steve and Sally. Let's look at the software effort for the system now. As you might expect with the first Shlaer-Mellor book being published, plus having Leon on board, the application analysis was fairly close to the OOA models we know today. The only exception was the state models being of the Mealy variety. Note, however, that the analysis tools were quite minimal. On the architecture side, this lack of tooling was compensated for by creating textual representations of the OOA models, something a good case tool would have done. These models could then be automatically translated into implementation structures in Informix and C. A data-driven state machine engine was also developed for the architecture. An interesting aside here is that some of the state models were implemented on the PLCs, and they also developed a data-driven state machine engine using ladder logic, no less. The models were clearly valuable artifacts. Note also the use of third-party software in the architecture in the form of the Informix database for handling the data. As with previous systems, the regular patterns of the architecture offered numerous opportunities for tooling, which greatly facilitated the development and the deployment of the system. As designed, the software architecture was reusable in 11 diverse manufacturing areas, thereby significantly reducing the overall development time. By AT&T's estimate, it cut the development testing time for an area in half. The third and final project we'll look at was 6 years after the previous one. At this point, Steve and Sally's second book, Modeling the World in States, had been published, and magazine articles on recursive design had been circulated. I was working at Project Technology at that point and consulted on both the application analysis and the software architecture for this project. The product for this project was developed by Sybase for Bell South and was an early media streaming application, think Netflix, a classic client-server application. The platform we deployed on was an HP Blade running Unix. The implementation technologies included C, the Sybase database, and an application server, Open Server Framework, developed by Sybase. Guidance for the software architecture was well developed at this point with Steve and Sally's books and publications. In addition, the project used an early version of the Bridgepoint case tool, which provided additional guidance. Let's look at the software for this system. With the method well developed, the application analysis on this project faithfully adhered to the Shlaer-Mellor method. This was further facilitated by the use of the Bridgepoint case tool. The functional Mealy state models were no longer to be seen again. On the architecture side, there were two significant advances. First was the use of the case tool's textual representation of the graphic models. These were used for input for generating a significant amount of code for the system, as the information and state models were mapped directly into database structures using project-developed tools. The second significant advance was the use of the Open Server Framework, which provided a significant amount of functionality for the software architecture as an implemented domain. This project existed in a very competitive environment, including an IBM Oracle team seeking the same contract. Using the Shlaer-Mellor method, the Sybase team was able to quickly produce a proof of concept with a simple software architecture, thereby proving functional compliance and winning the contract. Then they were able to tune the architecture without altering the application models to provide performance compliance. Separation of the application from the implementation, one of the defining characteristics of the Shlaer-Mellor method, paid very big dividends on this project. I think this is another important aha moment in the software development. Okay, here's a brief summary of the three projects we looked at today. The OOA row shows the evolution of the application modeling from simple ER diagrams and functional state models, ending up with complete Shlaer-Mellor analysis models. The RD row shows the evolution of the software architecture through these projects in terms of, number one, the percentage of automated, prescriptive, and elaborative mappings of the application models. Notice the increase in automation and decrease in elaboration. And two, in the use of case tools, going from simple drawing tools initially to a commercially available case tool on the last project targeted at automated code generation. Overall, I'd say not bad progress. In ending, I'd like to offer sincere thanks to Sally and Steve for their stellar insights and efforts in developing the method. Sincere thanks to all the first-generation practitioners also who expended significant effort in turning the theory into practice and feeding that practice back into the theory. My encouragement to subsequent practitioners of Shlaer-Mellor, you have a brilliant method to build on, and my condolences to those who might not get it and toil on. Thank you.